Imagine for a second that you're standing on the floor of an American steel mill in 1919. The first thing that hits you isn't just the noise, it's the heat. It's an oppressive, physical weight. And then you look up. Swinging 60 feet above your head is a ladle carrying 200 tons of molten steel. It's glowing white, bubbling at 2,900 degrees Fahrenheit. At that temperature, steel isn't a solid anymore. It's a liquid fire that can vaporize a human being in a heartbeat. Back then, these mills were the engine of the world. They were forging the skyscrapers of New York and the battleships of the Atlantic. But there was a haunting question lingering in the soot-filled air. Was the horrific number of deaths just the unavoidable price of building a modern nation? Or was it a cost we unfairly forced the working class to pay just to keep the profit margins high? To find the answer, we have to look at a time when engineering was moving faster than our conscience. Part 1. The Engineering Gamble. If we go back to the 1880s, things changed when Andrew Carnegie brought in the open hearth process. It was an economic miracle. It let mills recycle scrap metal and create massive batches of steel. But it also created a logistical nightmare. Suddenly, we weren't just moving 15 tons of metal. We were moving 100, then 200, then 300 tons at a time. And here's the thing, 19th century technology just wasn't ready for that kind of stress. Think about the cables. We used wire ropes made of hundreds of tiny steel strands. They were flexible, sure, but they had a hidden enemy called internal fatigue. Because of the extreme radiant heat coming off those ladles, the steel inside the cables would develop microscopic cracks. You couldn't see them from the outside. A cable might look perfectly fine on Tuesday morning and then simply snap by Tuesday afternoon. To make matters worse, we switched from old steam hoists to electric overhead cranes. These machines were powerful, but they turned the factory floor into a death zone. If a motor stalled or a hook bent under the heat, that liquid fire didn't just spill, it consumed everything in its path. Part 2. The Production Machine. Between 1890 and 1910, the industry didn't just grow, it exploded. We went from producing about 1 million tons of steel to 24 million tons in just 30 years. But that growth wasn't just coming from better machines, it was coming from pushing equipment and men to the absolute breaking point. At places like the Homestead Works, they ran 16 furnaces around the clock. The ladles were massive, lined with heavy fire brick, and the hooks holding them were constantly deforming under the weight. Engineers knew about something called creep, where metal slowly stretches and weakens when it's hot, but in the rush to meet quotas, maintenance was usually the first thing to be ignored. Part 3. The Human Toll, the Long Turn. But if you really want to understand the danger, you have to look at the people. The schedule in 1919 was, frankly, brutal. Most guys worked 12 hours a day, 7 days a week, and every 2 weeks when they swapped from the day shift to the night shift. And they had to work what they called the long turn, a full 24 hours of continuous labor. Now, imagine being a crane operator at the 20th hour of a 24-hour shift. You're sitting in a tiny cab 60 feet up. The air around you is 150 degrees Fahrenheit. The heat waves are so thick they distort your vision, making it impossible to tell exactly where the ladle is. These operators ended up developing a sort of sixth sense. They'd tap their levers just to feel the vibration of the cables, listening for a high-pitched ping, the sound of a single strand of steel snapping inside the rope. If they heard that, they knew they were seconds away from a catastrophe. The turnover was insane, sometimes 300% a year. People would join, see the conditions, and quit. The ones who stayed drank gallons of water just to keep from collapsing. But heat stroke was just part of the job. Part 4. When the system fails, history shows us that these disasters were rarely just accidents. They were cascading failures. Take the Struthers furnace explosion. It started with a worn cable, a mechanical failure. The cable snapped, the ladle dropped, and the molten steel hit a pit where water had collected because of a clogged drain, a maintenance failure. When 2,900 degrees Fahrenheit steel hits water, it's not just a splash, It's a steam explosion that acts like dynamite. In Allegheny County alone, back in 1906, a steel worker was killed on average every 2 days. Every 2 days, a family lost a father or a son. Part 5. Part the legal shield. And back then, the law wasn't on the workers' side. They had these cold legal doctrines like contributory negligence. Basically, if a worker made even a tiny mistake, like tripping while trying to run away from a spill, the company didn't have to pay a dime. Or assumption of risk, which basically said, you knew this was dangerous when you took the job, so it's your fault. Most families walked away with nothing but $100 for funeral expenses. That was the value of a life in the eyes of the industrial titans. Part 6. The turning point. Eventually, the public outcry became too loud to ignore. After the Triangle Shirtwaist Fire in 1911, the national conscience finally started to wake up. By 1920, we saw the rise of workers' compensation. This was a grand bargain. Workers gave up their right to sue for millions, and in exchange, the company had to pay out automatically for injuries. Suddenly, for the first time, safety had a price tag. It became cheaper for a CEO to fix a crane than to keep paying out death benefits. That's when we saw the shift: better steel for cables, larger pulleys to reduce stress, and the first warning sirens. Part 7. The rise of OSHA and the end of an era. But even then, real change took forever. We went through the 30s, 40s, and 50s with thousands of deaths every year. It wasn't until 1970 that the government finally stepped in with OSHA, the Occupational Safety and Health Act. OSHA took all that tribal knowledge from the old crane operators and turned it into federal law. They mandated inspections. They required certifications. They gave inspectors the power to shut down a mill on the spot if they saw a frayed cable. It was a revolution, but it arrived nearly 60 years too late for the men of 1919. By the 1980s, on the old open hearth furnaces were being torn down, replaced by faster, safer technology that required fewer people to be in harm's way. Towns like Pittsburgh and Youngstown saw their mills close, leaving behind rusted skeletons of the cranes that once built America. Conclusion. The legacy. So, what is the legacy of the 1919 steel mills? It's a story of incredible ambition, but also a sobering reminder of the silent costs of progress. The thousands of workers who died weren't just statistics. They were the involuntary pioneers of the safety standards we have today. Every time you see a safety harness, a load sensor, or a mandatory brake, you're looking at a lesson learned through tragedy in a smoke-filled mill a century ago. The steel hasn't changed. It's still just as hot and just as heavy. What changed was us. We finally decided that no amount of production is worth the cost of a human life. Engineering should protect the person, not just move the product. It's a simple lesson, but it was paid for in blood and fire.